All right, what's up, everybody? Welcome back to another live stream from the Scale It Learning channel. And if you're watching from the West Coast in California, good morning. It is 8:15. If you're elsewhere in the world, it might be later. International students, it might be in the evening, which is why I kind of wanted to get up and do this early, so it's not too late for you guys. All right, just checking the audio. All right. I am just waking up, so that's why I might look a little bit tired, but don't worry. I will be kind of waking up more and more as we get further in. So welcome, everybody. And if you're taking the SAT tomorrow, whether it's digital or US, this video is going to be for you. It's going to be a general conceptual review. What's up, Rawa, Tamir, Arian? Yep, we started. Welcome, everybody. But yeah, so today we're going to start with a sort of like the conceptual review, or it's all going to be conceptual. It's going to be about the 23 essential formulas. I have a video for this. Some of you may have seen it. If you haven't, we're going to go through every formula and just talk about them. And then we're going to go through my 41 strategies series. That's the most popular series on my channel for SAT math. So we're going to go through the strategies and talk about them in relation to particular problems, and that's that. So without further ado, let's do this. And feel free to shoot me questions in the comments or in the chat as we go along, and just kind of take it from there. All right, here we go. All right, first is the slope of a line equation. You got to know this equation. It's the difference of the y values over the difference of the x values for any 2 points. And here's an example. We got these two coordinates. It would see again. And what I like to do, this is kind of an example. I like to stack the coordinates and subtract down, so I have sort of a framework. And you see, I'm doing 2 minus 1 on top, 7 minus 5 on the bottom. So that way, I'm doing up, down, so the ordering doesn't get mixed up. And that would give me a slope of 1 over 2. Boom, done. Now let's talk about slope-intercept form. A very, very important formula. Y equals mx plus b. M is, of course, the slope. B is the y-intercept. So you got to know this format because, sorry, there's going to be questions, of course, on the SAT where it's going to be in this format, or you have to put it in this format and then figure out the slope, figure out the y-intercept. So, for example, here the slope is 2. Which you can see, the y-intercept is 7, which you can see represented here on the graph, and the slope is 2, meaning to go to the next point or a next point, you would go up 2 and then to the right by 1. So the reason for that 1, by the way, is every whole number is really a fraction over 1, right? So when we say 2, it's not just 2, it's 2 over 1. 7 is 7 over 1, etc. Point slope, another great formula where, again, m is your slope value, but now we can construct the line from a coordinate, okay? And that's what x1 and y1 comprise. They can be any coordinate, so you can have multiple equations for the same line. So if we were to graph this one, for example, it would contain the point 3, 4. And it would have a slope of 3/2, which means it would go up 3 over 2, right? You see that? Up 3 over 2. Now, that's like actually going down 3 to the left 2, but it's the same idea. Going down 3 and to the left 2 is the same as going up 3 and to the right 2, because if we went up and up, you see, we'd still land on that line. All right, midpoint formula. Here we go. And really, what is the midpoint? You're taking the average of the x values, the average of the y values. Boom. Why does that make sense? Because you're literally finding the middle of 2 points. Hence, adding them together, dividing by 2. So if we take an example here, hey, what's the midpoint of 8, 4, and 6, 7? We add the 8, 6, and we divide by 2. That would be 14 divided by 2 is 7. Add the 4 plus 7, divide that by 2. That's 11 over 2. So the midpoint would be at 7, 11/2, or 5.5. All right, distance formula. This one is going to be helpful. I'd say if you're trying to find the length of a radius in a circle that's unknown. They give you the center and an endpoint. Distance formula, you take the difference of, you take two coordinates, you take the difference of the x values, square it, difference of the y values, square it, add those together, and then take the square root of that entire piece. So for example, the distance between these 2 points, you see, I'm subtracting the x values, subtracting the y values. 5 minus 1 is 4 squared, 3 minus 0 is 3, and then that's squared, so it becomes 16 plus 9 is 25. Square root of 25 is 5. Length of an arc. Okay, what is an arc? Length of an arc means like piece of a circle, okay? So if we look here, this is an arc length is that red piece. And the way you do it is kind of intuitive. It's circumference, 2 pi r, times the fraction of that central angle that takes out that sort of arc length over 360. So it's like the fraction of the central angle over the whole circle times the circumference. And that's that. The reason why I didn't include 2 pi r itself as an equation here is because that will be given to you on the SAT on the formula sheet. Now we have the area of a sector, okay? That is similar to arc length because I'm taking the area of a circle, pi r squared, and I'm doing the same fraction multiplication, central angle over 360. So that's that. Here you can see what that looks like. It almost looks like a slice of pizza, right? That's area of a sector. So we're taking that little piece of pizza, and that's how we're calculating the area. Okay, quadratic formula. Famous formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And what do all these letters mean? Well, if I have a quadratic and it's in standard form, I got my a, my b, my c, that's what I'm plugging in. And what is it finding? It's finding the zeros of a quadratic, meaning the x-intercepts of a quadratic, okay? If the quadratic already is equaling 0, you're getting the solutions, but when it's in a, like a y equals form, excuse me, again, you're finding the x-intercepts. All right, here we go. Next is SOHCAHTOA. All right. SOHCAHTOA is our trigonometry mnemonic device, and it tells us or reminds us that sine of an angle is opposite over hypotenuse, cosine of an angle is adjacent over hypotenuse, and tangent of an angle is opposite over adjacent. All right. Probability in sum, what you want to think about, it's if you're trying to find the probability of anything, it's the number of favorable outcomes, the number of ways to win, I always say, over the total number of outcomes. Case in point, you're rolling a dice. Let's say you win by getting a 3. So the way your number of favorable outcomes is 1, okay? Your total number of outcomes is 6 because it's a dice. You get 1, 2, 3, 4, 5, 6, so your odds of winning are 1 out of 6. Okay, the circle equation, very important. It's almost always on at least one question per test. And this is the circle equation. If we have a circle, that's the center. H comma k. Okay, so it's presented with the x minus the x value of the center, y minus the y value of the center. And that r squared on the other side is the radius squared, meaning the radius is simply the square root of that, which is just r. Okay? So in this example, you'd have a center of positive 2, negative 5. Again, it's opposite, right? It's supposed to be y minus the center, x minus the center. And a radius of the square root of 36, which is just 6. All right, exponential growth. This is the general formula for exponential growth. It's, again, a, which is your initial value, times 1 plus r. R is the rate or percent of growth, right? It's growing by 50%, that'd be 0.5. And then t is usually your time value. Usually. Could be something else, but. And, again, initial value, growth rate, and time. So as an example, we got initial value of 200, growth rate of 13% or 0.13, and time in 3 years would be represented as follows. And exponential decay, the initial value is 150, decay rate 9%. Now we're talking about exponential decay. We're losing value. This is where that minus would come in, right? Now it's not 1 plus 0.09, it's 1 minus 0.09 because we're losing value. And that would be it. And so again, inside what you'll see is 0.91. But so anyways, there you go. And the key differentiator between exponential decay and linear, decline is exponential decay. It's decreasing, but the amount you're decreasing by is changing. It's actually lessening every year. Just like with exponential growth, the amount you're increasing by is changing, but it's growing every year, right? Versus linear is just a consistent amount. Okay. Just checking on my coffee. All right. Vertex of a parabola. Again, a parabola, same as a quadratic. Right, if you're just trying to find the vertex in standard form, you just go, boom, negative b, whatever that value is, over 2a. And that's it. Very important. And if you want to find the corresponding y value of the vertex, you take that x value, plug it in. Vertex form of a quadratic. Again, this is standard form. Vertex form is this. Now, sometimes it might be given to you in vertex form, okay? And they'll be like, hey, what is the vertex? Well, you have to recognize it as such and say, oh, my vertex is h, comma, k, okay? Again, the sign of h is flipped, k is not. That a value in front dictates whether or not you're going up or down based on its sign. So if it's positive, you're opening up, negative, you're opening down. Pythagorean theorem, I believe this is on the actual formula sheet, but I like to give it anyways. It's such a central formula in mathematics. So this is a squared plus b squared equals c squared for any right triangle where a and b are the legs. Doesn't matter which is which. B doesn't have to be the bigger one. It can be, but doesn't have to be. And then c is, of course, that longest side, the hypotenuse opposite the 90 degrees. Distance equals rate times time. Simple, but very, very powerful, right? Distance equals rate times time. And there's a lot of distance and rate problems and stuff. And you might say, well, this is formula, it's so simple, what's the point? But I'm telling you, it's nice to just make sure you have it fresh in your mind and to apply it when need be. Okay. Sine and cosine, you know sine and cosine, but this is a special rule between sine and cosine that the College Board loves to test. And that is that sine of an angle equals cosine of the complement of that angle. All right. And what does that mean? It means that the two angles must add up to 90. So, for example, sine of 10 equals cosine of 80. Sine of 20 equals cosine of 70. We could do this all day, right? Any values that add up to 90, you take sine of one, take cosine of the other one, they're going to equal each other. All right, this is the sum of solutions of a quadratic. If you have a quadratic and they say, hey, it's equal to 0, what are not the solutions, what are the sum of solutions? There's a nice little shortcut because you could solve it and add them together. That might take a while, especially if you have to use a quadratic formula. Or take this little shortcut, negative b over a, and then boom, you're done. For example here, what's the sum of the solutions? Negative 7 over positive 2, right? Negative b over a. That's it. You're out. The discriminant. Again, quadratics, okay? What is the discriminant? Well, you might notice it. That's that little piece from the quadratic formula that's under the radical. This is going to tell you how many solutions you have and the nature of the solutions. For example, in this case, my discriminant would be negative, right? 9 minus, 40? It would be negative 31. That's negative, which means we've got no real solutions. Again, this is logical because if that's under the radical in the quadratic formula, that's going to be square root of a negative. That does not exist in the real world realm. Therefore, no real solution. Or we could have the discriminant equaling exactly 0. In this case, we have one real solution. That makes sense too, because if you get rid of the radical, no more plus or minus. So it's just one solution. Okay, and the last case is, of course, it's greater than 0. And this would be two real solutions, okay? Two real unique solutions. Okay. Next, area of an equilateral triangle. Not as essential, but a nice one to have in your pocket. Okay, it is simply s squared, side length squared, times the square root of 3 over 4. The reason why I say you can get away without knowing this is because an equilateral triangle can be divided like this into a 30, 60, 90. And then you can use special right triangles, which are given on the formula sheet, right? But it's not too bad if you know it. For example, this one would be 1 times square root of 3 over 4. This one would be 4 times the square root of 3 over 4. They would cancel out, obviously, the 4's, but... And then this one would be 9 times the square root of 3 over 4. Pythagorean triples. This is something great to know. It's not, again, you can determine these values by using the Pythagorean theorem, but... If you know Pythagorean triples, look how amazing this is. You know a 3, 4, 5 is a triple. But not just 3, 4, 5. That would be multiples of 3, 4, 5, which we're going to get to in a second. Another important one is a 5, 12, 13. 7, 24, 25 shows up less frequently, but... And 8, 15, 17. I'd say that one shows up more than the 7, 24, 25 on the SAT. And with these come their multiples, okay, that you know will be corresponding values, right? 3, 4, 5 is 6, 8, 10, 9, 12, 15, etc. Those are the multiples of 5, 12, 13, 7, 24, 25, and these are all the multiples of 8, 15, 17. All right. 22, perpendicular slope. We know that if slope of a line is a over b, perpendicular slope would be the negative reciprocal, aka negative b over a. All right? So, for example, hey, look at this linear equation. We have a slope of 2/3. All right, a perpendicular line would contain negative 3/2, the negative reciprocal. Okay, last one, sum of angles in a polygon. So here's the formula, and this is going to tell you if you have a pentagon, right, and would be the number of sides, okay, you plug in 5, you say, hold on. You plug in, excuse me, you plug in 5, you get 5 minus 2, which is 3. 3 times 180 is 540. That's the sum of the angle measures in a pentagon. If we look at a triangle, you get 180. You gotta know that the angles in a triangle add up to 180. This one, rectangle, 4 sides, 4 minus 2, 360. That makes sense, right? Square, rectangle, adds up to 360. And then a pentagon, the example that I was just talking about. Okay. All right, that concludes the formulas portion. Whoops. Now we're going to talk about my 41 strategies to get a perfect 800. You guys may have seen this series, or at least part of it. We're going to go through everything today. And by the way, if you are enjoying what you're seeing, if you're finding it helpful, make sure to click that like button. Really helps the channel. Feel free, again, to leave something in the chat or the comments as well. All right. So, and Aylin is asking if I can solve some questions. Today, we're going to have some questions right now in the strategies portion, but I'm not going to be doing like a practice walkthrough, but we're going to be doing questions for each strategy that I'm going to be talking about. Let me load my thing here. 1 second. Oh, wait. Oh, shoot. Hold on 1 second. Sorry, guys. 1 second. Oh, there we go. All right. We are ready to start. Cool. Okay, here we go. Oh yes, thank you guys so much for those likes. I appreciate that. See, some people gave me a couple. Thank you, thank you. Here we go. Tip 1. Label your proportions. So what are we talking about in this question? We're talking about 400 total light bulbs produced and 7, being selected. So it's like, if we're going to set up a proportion, right, which this is a proportion problem, look at how I'm labeling stuff. And you might say, well, I don't usually label. It's not too bad. But this just, man, it really makes it so much easier, and it barely takes any time. So we're selecting 7 out of a total of 400. So I want to know how many are we selecting with a total of 20,000. Boom. Now I know not to misplace any of these values. Cross multiply equals 140,000. Divide by 400. You see? Like this. Cancel out those zeros. So it ends up being 1,400 divided by 4. So that is 350. Boom, done. Tip number 2, use conversion factors. Okay, so check this out. Distance traveled is this many miles, and it makes an orbit in 1 year. Of the following, which is close to the average speed in miles per hour. Okay, so we're saying, hey, we go 580,000. Or sorry, million. What am I saying? 1, 2, 3 million miles in 1 year. Okay, so how do we do this conversion? We're going to do it step by step. So first, we're in miles up here. And, I want to stay in miles, right? I just want to convert that year to hours. So check this out. I'm going to do it piece by piece. First, I know 1 year is 365 days. Cancel. Then I know 1 day is 24 hours. And there we go. Now I know what to do using the conversion factors. I don't have to worry about, hey, am I dividing, am I multiplying wrong, this and that. No. Now I see, oops, 1 second. Now I see I multiply these together, and then I'm dividing 580 million by that amount. 1 second. I think my coffee is here, guys. 1 sec, guys. Oh, 1 second. Hello? Hello? Okay. No, not yet. Hold on. Oh, yeah. I think it's here. Give me 2 seconds. Just grabbing it here. All right, sorry about that, guys. My alarm went off. It's crazy. Okay, here we go. Boom. We're back. Okay. So anyways, as I was saying, now we can do this division. So let's do it over here. So 580,123,123 divided by 365 times 24. Boom. And there it is, about 66,000. So that's how you do it. Next. All right, tip number 3. Use the percent equation. Man, this thing is really powerful on these percent problems. I'm going to show you how we're going to use it. So, you're talking about all this stuff. She bought it at a 20% discount off its original price. So immediately I'm like, okay, we got an original price that's unknown. We got a 20% discount. And then she paid a total, which is P dollars, which included also an 8% sales tax. Again, I'm also underlining my numbers. Remember that. And variables. Okay, and then she said, what is the original price in terms of P? Well, I'm not even going to think about this too much, okay? I'm just going to say, all right, well, I've got an original price, and I'm going to create an equation that explains the scenario, meaning first I got a 20% discount, but when I take off 20%, I'm really paying 80%, so that represents that. And then I'm adding an 8% sales tax, and this equals P, because this is what I'm paying. There's my equation. Nice. I just represented the situation. Then they want me to solve for X. They said, which of the following is the original price in terms of P? Well, all I'm doing is solving. Now, normally I'd multiply these together and divide by that, but you can see in the answers, they didn't do that. So we just divide by what we got here, which is 1.08 times 0.8. D is the winner. Boom, done. All right, tip number 4, translate into an equation as you read. Okay, so watch this. And I do this all the time if you've seen my live streams. If 16 plus 4x is, that's like equal, 10 more than 14, what is the value of 8x? Look at that. We got our equation. I'll also show you a little shortcut here too. That's going to be 24. Then I'm going to subtract 16 from both sides. I got 4x equals 8. Now, you can solve for x if you want, or since we're trying to get 8x, multiply both sides by 2. 8x equals 16. Boom, done. But of course, x would equal 2. Plug it in here. 2 times 8 is 16. Same thing. All right. Number 5. Know the slope and the y-intercept. And again, slope is k, y-intercept is 4. Now, in this question, that's what you're trying to solve for. You're trying to solve for k. What is the slope? But in terms of C and D, and they said C and D is a point, x and xy coordinate. So when in doubt, plug in, right? C is an x value, D is a y value. So I'll say D equals kc plus 4. And then isolate, because they said, what's the slope? Solve for k. That's it. Then you just rely on your algebra skills. D minus 4 equals k times c. Divide by c, get rid of that. And then now we have our slope. D minus 4 over c. Boom, done. Tip number 6. Plug and chug. This is huge, okay? Especially in these long word problems. Look at this, okay? We're talking about the equation that convert between Celsius and Fahrenheit. Sorry, one sec. Forgot to even drink my coffee since it's arrived. And we got this question. Now, this is a pretty hard question, okay? Increase of 1 degree is equivalent to 5 nines. Increase of 5 nines, you know, all this stuff. But watch how nice plugging in is. Celsius, Fahrenheit. I'm going to make a little table as well. They said an increase of 1 degree Fahrenheit is equivalent to 5 nines Celsius increase. Let's see. Let's choose 2 values of Fahrenheit, easy ones. If Fahrenheit is 32, Celsius is 0. 32 minus 32 is 0. What about 33? That's a 1 degree increase of Fahrenheit. Plug it in. 33 minus 32 is 1 times 5 nines, 5 nines. Well, look at that. 1 degree up here went up 5 nines here. This is true. A temperature increase of 1 degree Celsius is equivalent to 1.8 Fahrenheit. Okay, let's try it. Again, we got 0 here for 32 Fahrenheit. Let's make it up to go to 1 for Celsius. Okay? If Celsius is 1 degrees, how do we solve for this? We multiply both sides by 9/5, right? Isolating. Here's 1. So we have 9/5 equals f minus 32. Then we're going to add 32 to both sides. And what is 9/5? It actually is 1.8. 32 plus 1.8 is 33.8. Look at that. It did go up by 1.8. So you can see we can test it even when it feels a little convoluted. So I already know the answer is 1 and 2. No, the choice for 1, 2, and 3. 3 happens to be wrong. Boom, done. Okay, tip 7. Isolate, 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 right? We basically did that just now, to be honest. But what is the value of w? Just get the w by itself. How do we do that? Get rid of the 3/5, which means we multiply by the reciprocal 5/3, and we get 20 over 9. Boom. Next. Okay. Now, when you have these systems of linear inequalities, all right, again, this is one of the topics, right? Every one of these is a subtopic. When you have one of these problems, you're going to be evaluating or trying to create equations for two different relationships via inequalities. And then you have to be like, hey, the correct choice needs to have both of them. Well, I say start with the simplest first. What do I mean? Let's read this. We got two different types of boxes, 40 or 65 pounds. X is the number of 40 pounds. Y is the number of 65. And we can carry either 45 or a weight of 2,400 pounds. Okay. My easiest relationship is this. Because this is my number of boxes. So I know that the total number of boxes has to be less than or equal to 45. That's my simplest relationship. Which one of these has it? A and B. Which one of these doesn't? C and D. I've already got it down to two choices. Now, the second one, we know that, each one of these is 40 pounds. So which one makes more sense? This equation or this one? And it's going to be the top one, because why are you dividing by the weight? Like if I have two boxes, that weighs 80 pounds. Two boxes doesn't weigh 2 over 40, right? This doesn't make any sense. But anyways, starting with the simpler relationship first, we immediately eliminate two choices. Boom, done. Tip number 9. All right. Oh, hey, Buttery Big Mac. Thank you. Appreciate that. Solving systems of linear equations. Here we go with this category, elimination over substitution. I'm a big fan of elimination comparatively and almost always use it. We're trying to get a solution to this system. Let me show you. So I'm going to match up one of the variables to be same coefficients but just opposites. So look at this. Easily I can multiply the top by 2. I got negative 6x plus 8y equals 40. On the bottom, 6x plus 3y equals 15. Add these together. Goodbye, right? Those cancel out. 11y equals 55. Y equals 5. Boom. And then quickly to find x, plug and chug. Plug it into the top one arbitrarily. You can plug it into either negative 3x plus 4 times 5 is 20 equals 20. Cancel, cancel. Negative 3x equals 0, which means x equals 0. And we want to check it, right? If x equals 0, y equals 5, it equals 20. X equals 0, y equals 5, it equals 15. Boom, done. All right, linear inequality problems. Think slope-intercept form. Again, let's check this out. The boat rental costs $60 per hour. That's my slope. And she will also have to pay for a safety course that costs $10. That's my y-intercept. That's how much you're paying regardless of how much time you spend, right? Got to pay $10. Maria wants to spend no more than $280 because this is the amount she's spending. So I'm coming up with this relationship with this equation using slope-intercept form. Rate of change times, that time unit plus my y-intercept. What is the maximum? And then we have our equation that we solve. Minus 10 from both sides. 60x is less than or equal to 270. Divide by 60. Divide by 60. Boom, boom. Cancel the zeros. 27. 6 goes into 27 4.5 times. So the max number of hours, which is a whole number in this case, would be 4. Okay, this one. Identify relevant numbers is our tip here. Now, they say between these 2 years, are they relevant numbers? Well, I don't know, but I'm going to underline them first. We're going to see. He's gone to the New World. First voyage lasted 43 days longer than the second voyage. Okay, oops, not 43, sorry. If the second voyage is x, the first one is 43 longer. X was 43. And the two voyages combined lasted this many days. How many days did the second voyage last? Notice, these numbers ended up being irrelevant. So even though we've underlined them, not every number you're necessarily going to use, they're going to do this. You can call them red herrings, call them whatever, but just be wary. But we don't need that. We just say, hey, these two together equals 1,003. That's what it says. So I'm just going to put it into equation format. And then we're going to solve. Minus 43 from both sides. Boom. So we get 2x equals 960. And then divide by 2, we get 480. Now, we go back to the original chart. Notice I leave this here because it says how many did the second voyage last. The first one, you add 43, not the second one. It's just x. So it's 480. Boom, done. Okay, here we go. Graph of the function in the xy plane above is a parabola. Which of the following defines f? Vertex form. We talked about this in the formula sheet, right? You got to know this to understand this question because this is in vertex form, right? And where's the vertex? Right there. So it should be x minus 3 squared plus 1. The thing is, we have that in two places. Whoops. We have it in A and C. But this one has an A value. So which one is right? Now we plug and chug, now we test. Because we got other points. We know that when we plug 4 in for x, we should get 5. Well, here if I plug 4 in, I don't get 5, I get 2. But if I throw a 4 in front, 4 minus 1 is 1, squared is 1, times 4 is 4, plus 1 is 5. Oh, look at that, we get 5. So A is the winner. Okay, key features of graph. Analyze the entire graph before reviewing choices. So check this out. Before I go in and just read and then look and then go back, I'm like, what is this? Speed. So we're starting flat, then we're going up to 7 miles per hour, staying consistently, then kind of slowing down to 5, speeding up. Here's my max speed. Okay, I got my head around it. Takes me 5 seconds, maybe 10. Then I jump in. Runs on the treadmill for 30 minutes. Which of the following is not true? Okay. Constant speed for 5 minutes. That's true. There's my constant speed. That's where it didn't change. Teresa's speed was increasing for a longer period of time than it was decreasing. Increasing. Increasing. So that's increasing for 10 minutes. It's decreasing for 15. So that's not true. Oh, well, that's the answer, I guess. But anyways, and then the speed decreased at a constant rate during the last 5 minutes. That is true. And her speed reached its maximum during the last 10 minutes. Yes, it did. Right here's the last 10 minutes. There's the max. So anyways, B is the answer. All right, 14. No slope versus y-intercept. The value multiplying the variable is the slope. Here's your y-intercept, your starting value, okay? So they said, what is the meaning of 1.88? Well, it's the slope. That's my rate of change. That is the change in y over one change in x. Meaning, this is the change in the height every 1 inch, the length of, based on the length L of the femur. Okay, so where is that? The approximate increase in a man's height for 1 inch in the femur. That's slope. Okay, next. Recognize vertex form versus intercept form. Which of the following is equivalent where you see the minimum value of f appear as a constant or coefficient? What are they talking about? Where you see the minimum for vertex? When it's in vertex form. Okay. These are not even in vertex form. So it's one of these two. Now the question is, which one is the right one? Well, this tells me the intercepts are at -6 and 4. So I can use this to find my x value of the vertex. Because it's right in the middle of the x-intercept. So what's the middle or average of negative 6 and 4? You add them together, it's negative 2 divided by 2 is negative 1. So the vertex should be at x plus 1, which is the negative 1, which is D, not minus 1. D is the winner, boom, done. Okay. Eliminate options using positives and negatives. Which of the following is equivalent to the above expression? Okay. So what they really did is they did completing the square. But, you know, I mean, maybe you might not remember that. You might not want to do that. So we'll take an easier route. All right. We can do a little plug and chug here. Okay. So, for example, if I plug in negative 3, and the reason why I'm choosing negative 3 is because, you know, that's going to cancel those out. And I'm going to also choose positive 3 to look at those. That'll be easier. So check this out. Negative 3 in the original equation should equal whatever we plug in negative 3 into the right answer choice. So that's 9 minus 18 is negative 9 plus 4 is negative 5. Okay. Negative 3. This would give me positive 5. Negative 3 would give me negative 5. So we already eliminated 1. What about positive 3? 9 plus 18, 27, plus 4 is 31. Positive 3. This does not give me 31. Positive 3. Oh, wait. Hold on. Did I do that wrong? Uh-oh. Wait. Negative 3. Oh. Negative 3. Wait. What did I just do? 9, negative 18, negative 9, negative 5. Negative 3 is... And then what did I just plug in? I said positive 3 gives me 9, 27, 31. Well, that's weird. Hold on one second. 9, negative 18. Shoot. This is not working out how I... Wait. I'm having a brain malfunction. 1 second. Let me start that over. So you plug in negative 3 up here. That would be 9. Negative 3 times that is negative 18 plus 4. That's negative 9 plus 4 is negative 5. So plugging in negative 3, we'd get negative, that would be positive 5. Plug in negative, and then plugging in, so then I eliminated this one. And then plugging in positive 3 gives me 9 plus 18, which is 30. But the only one that's 6, that's... What am I doing wrong here? 9 plus 18, 27 is 31. I'm like totally tripping out right now, guys. Hold on, sorry, 1 second. Which the following is equivalent to the expression above. I'm just going to complete the square and reverse engineer this. So this is the actual way they want you to do this. So you add half of this value squared, which is 9, but then you also have to subtract it, and then this becomes minus 5, and then it becomes x plus 3 squared minus 5. But then for some reason... Oh, what am I doing? When you oh, sorry, it is that one. And then, sorry, my bad. When you plug in, I don't know why I miscalculated that. Yeah, it is that one. But then when you plug in positive 3, you get 31, right? And then here, plug in 3, you get 3 plus 3 is 6. 6 squared is 36 minus 5 is 31. That was the way I was trying to show you without actually having to complete the square. But yeah, B is the answer. And then plug in positive 3 here, you only get 5 and negative 5, so those are out. That was meant to be much faster. I don't know, I was like miscalculating. Sorry about that. Yeah, thank you, Logan. Whoops. Sorry. Okay. Speaking of which, let's get some more caffeine in the blood. All right. Let's go. 17. All right. Binomials. Foil, right? Which of the following is equivalent to this? Don't just be like, hey, it's a squared plus b squared over 4. Don't do that. Okay? When you see this, you want to be foiling, meaning that binomial times itself. Okay? Like this. Distribute a squared. Distribute. That's ab over 2 plus ab over 2. It's just ab. and then distribute b squared over 4. D is the winner. Boom, done. All right, tip number 18. Know the formula to calculate mean. All right, so what is the formula? Total, or sum of everything, divided by the number of things that there are equals the mean. Okay, why is this so important? We'll check it out. The mean of 8 players in a basketball game was 14.5. If the highest score is removed, the mean of the remaining 7 players becomes 12. Okay. So what was the highest score? Well, what we can do is this. I can take this amount here, these two amounts, 8 with a mean of 14.5. That can give me the total, which is great. Because if I take the number of players times the mean, I go back to the total. So 8 times 14 is 80, 32, 112, 116. So there's my total. But now we're removing the highest score. And then we're dividing by my new number of players, 7, to get a new mean of 12. That's what I mean by using that formula. So we take these values, we plug them in. Now we have an equation that we can solve for that highest score value. Multiply both sides by 7. 116 minus x equals 84 minus 116. I should have done this in the calculator. This is a calculator, but, you know, it's all good. And then that is 16, 32. Negative x equals negative 32, which means x equals positive 32. Boom, done. Okay, this one. Memorize the formula for exponential growth and decay, which we already talked about. So Juan purchased an antique that had an initial value or value of 200 at the time of purchase. Each year, the value is estimated to increase 10% over the previous year. If you remember from the formula, that's 1 plus 0.10 or 1.1. And the estimated value of the antique 2 years after the purchase, and then we take it to the number of years, right? It's 10% per year. Can be represented or is equal to 200a, where a is a constant. Just by knowing this formula, I've made this question so much easier. Because, look, now I got a nice equation. I'm solved for a, divide by 200. A equals 1.1 squared. If you put that in your calculator, it's 1.21. Just like 11 squared is 121. That's it. Boom, done. Yes, Hypertop, I will be making many more math videos for sure. Here we go. Tip here, number 7, or 20 in this case, because we're doing the whole thing. Substitute and factor. This is shown in the graph. The function g, not shown, is defined by this, was one possible value of a. Okay. Such that the two functions are equal. So we're trying to figure out when these two are equal. Let's set them equal to each other. Boom. Substituting this in for the function value. All right. Whoops, what the heck? 1 second. What just happened? Just got a weird message. What? Hold on 1 second, guys. What was that? Okay, never mind. I don't know what's going on. Wait. I got a weird message on my phone. Okay, I think it's fine. All right. So now let's do our thing here. So first I'm gonna FOIL on the right side. Negative 1/2. If I FOIL that out, it becomes x squared minus 8x plus 16. Right? Because that's what happens. And then you distribute. Negative x plus 10 equals negative 1/2 x squared plus 4x. Negative 1/2 times 16 is negative 8. Let's see, what should we do here? Let's multiply everything by -2 to get rid of that 1/2 and make it positive. So then we got 2x minus 20 equals x squared minus 8x plus 16. Then I'm going to add 20. That's going to be 36. It's right up here. I'm going to subtract 2x. That's going to be negative 10x. And I still got the x squared here. And then we're going to factor this. What would it be? 4, 9, 12, 3. 12, 3, 9, 4, 6, 6. Make sure I didn't make a mistake here. Hold on. X squared. Hey, thank you, Sonriente. I appreciate that. X squared minus 8x plus 16, 1/2, negative 4x minus, plus 8, or minus 8. Just make sure I didn't make any mistakes here. And then we're doubling everything. So 2x, negative 20, positive x squared, negative 8x, positive 16, 36 minus 10. Yeah, I think that looks good. And then I'm just trying to factor this. This would be 6. Why can't I think? 12 and 3, 4 and 9, 6 and 6. Oh, it's not factorable for some reason. Wait, 12, 3. But then that would be 36. Wait, did I make a calculation mistake here? Negative x, it wouldn't be negative 9x, right? It'd be negative 10x. Minus 12 minus 3. Both negative adding to negative 10. Wait, hold on a second. Something went wrong. Oh, I forgot the plus 10. There you go. I've done that before. I made that mistake before on this problem. I feel like there should have been a plus 10 out here. Sorry, guys. Missed that. Anyways, so then there's a plus 10. So that would actually cancel out with this guy. So that's not a thing. So then it stays as 16. Yeah, there we go. Boop. Okay. And then we factor, boom, what two numbers multiply to 16, add to negative 10. It's minus 2 and minus 8. And so the two values would be, because this is equaling 0, by the way, now, right? The two values are either 2 or 8. Now, I can even graph this to show you, right? This is a function with a y-intercept of 10 and a slope of negative 1. But notice the way it's laid out, right? This is going up by 1 every 2. This is going up by 1 every 1. So anyways, the slope of negative 1 would be down 1 over 1. Down 1 over 1. So you can see, if I graph this out accurately, that reinforces what I just got. Your answers are either 2 or the other intersection is 8. So either one. All right, guys. Yeah, sorry. I just made a mistake when I was transposing the equation. 21, replace and simplify. Okay, so they said, what is f of negative 3x equal to? Well, they're basically plugging negative 3x in for x, and that's it. So negative 2 times negative 3x plus 5. That becomes 6x plus 5. B, boom, done. Tip number 22, fill in missing dimensions, okay? So in this case, they give us all this stuff. They say y equals 75. I'm going to put that in the mix. Then I said that 180 minus z equals 2y. I already know that y is 75. So 180, minus z equals 2 times 75, which is 150. Minus 180, negative z equals negative 30. Z equals positive 30. And now we can start to figure this stuff out. These sides are equal. These angles are equal. And if they are in a triangle with 30, they must add to 150. They must also be 75. Look how I'm filling it in. And then we get to the last part. X and 75 are a linear pair, which means x must equal 105 degrees. And that's that. All right, here we go. Yes, I have done these videos before. These are from my my 41 strategies video series. I'm just going to, I like to do this for everybody. People generally find it really useful, even though the content exists elsewhere. Just do it live, try and talk to you guys and make sure you guys are here to have some accountability, to make sure to get this fresh in your mind the day before. Okay, skip the nonsense. And what do I mean? This is in particular related to isolating quantities questions. Based on the current formula, what is W in terms of A? So, you know, we've read this. We kind of understand it. But when you get an isolating quantities question, okay, immediately recognize once you read through everything, based on current's formula, what are they doing? They're isolating W. So just, you know, don't overthink it. Just go, all right, cool. I'm going to isolate W. Multiply both sides by 30. And then subtract 4. 30A minus 4. A is the winner. Done. I think the digital SAT will be very similar to the practice ones that have been released by the College Board. That's usually how it goes. Obviously, the digital is a little newer. Maybe there's some unknowns, but it should be consistent. All right, this one, know your universe for table data. The left table, so I'm going to show you what I mean by that. So as we read this through, again, underlining the numbers, there are 5 times as many right-handed females as there are left-handed. And I can write that in, right? 5 times as many right-handed as there are left-handed. And there are 9 times as many right-handed as there are left-handed. 9 times, and I'm using a different variable. Okay. And then if there's a total of 18 left-handed and 122 right-handed in the table, which of the following is closest to the probability that a right-handed student selected at random is female? Now, we're going to come back to knowing your universe in a second. But first, let's solve for x and y. Well, I got 2 equations, right? I know that x plus y equals 18. And I also know that 5x plus 9y equals 122. All right. And now I got a system. I can solve for this. I can multiply this by -5 using elimination. And I can cancel this out. 9y minus 5y is 4y. 122 minus 90 is 32. So y equals 8. And then x equals 10, right? Coming back to this equation, 10 plus 8 is 18. And so now I know these values. I know that this is, what did I say? Is that 10? Can't even read it. Yeah, it's a 10. Sorry. This is 10. This is 90. This is 8. And this is 40. Sorry. What is this? Oh, wait. Whoopsies. I did that backwards. Sorry, let me do that again. I know that this is 8, excuse me. This is 10. This is 50. And 9 times 8 is 72. And then you can double check, right? Those add up to 122. Okay. Now it says, is close to probability that a right-handed student selected at random, meaning this is my universe. We're not selecting anybody that's left-handed. If you select a right-handed student, what's the probability that it's a female? So we got 122 right-handed students. 50 of them are female. There's your answer. So it's 50 divided by 122, which is 0.41. Boom, done. All right, line of best fit trumps the dot. This is in particular when they say, hey, what's the predicted percent, predicted whatever value, okay? So what they say for 3 years, right? Where's the, oh, sorry. Which finding source predicted percent leave in this particular, oh, sorry, it's based on the temperature, excuse me. So they gave us a temperature of -2. So where's -2? That's -3. Here's -2. So you come up here and you're like, wait a minute. Here's a value on the line of best fit, but here's a nice real value. Shouldn't I go with the real value? Shouldn't I say 82%? No, because it didn't say what was the actual value. It said, what is the predicted value? And that predicted value is around, I think, 70%, it looks like. Close enough to 70. I mean, it's the closest, right? 63 is way down here. That wouldn't make sense. So, yeah. Boom, done. Okay, this one, distinguishing between adding and multiplying. Which of the following best describes the mosquitoes? Is it linear or exponential? So if it's linear, you should be adding the same value every time. Clearly, we're not. So it's not linear. And then it's a matter of, right, we're multiplying by 10 every time. Multiplying, that's exponential. And is it growth or decay? Well, it's getting bigger. Growth. C is the winner, done. Okay. Tip 27. When solving exponents, get the same base. Okay, you'll notice immediately with this question, we got 8 and 2, both powers of 2. So 8 is 2 to the third, multiplied by x, 2 to the 3x. That's 2 to the y. That's great. When we have them in the same base, it's nice because now I can combine the exponents. I can subtract them, right? With a fraction is what you do. So that's what this expression is. Guess what? I know what 3x minus y is. It's 12. 2 to the 12th, boom, done. That's it. Okay, tip 28. Understand vertex, y-intercept, x-intercepts. Function goes here. What does the number 72 represent? Now, in a standard form, this value is your y-intercept. It's your, which means it's your starting value, initial value. Look at that. Initial height. We're done. This looks like a pretty hard question, actually, right? It's later in the game, 24. It's a lot of words, but you know your stuff. You know your quadratic stuff. Good to go. That's also my critical concept series, by the way. Okay. Let's go to the next one. All right, operating with rational expressions, which the following is equivalent to this. So it's nice if you know a little polynomial long division because that's what they're really getting at here. How do I know which one is equivalent to this? By the way, I can do a plug and chug. I can be like plug in 5 and which one of these gives you the same value. But watch this. That is division, right? And I'm going to show you how this works. If you remember, oops, oh boy. If you remember how to divide, you say, how many times does x go into x squared? Don't worry about the -3 right now. It goes in x times, and then you multiply. X times that is x squared minus 3x. Then we subtract, just like regular long division. Cancel. That becomes x. Bring down the -5. What times x gives me x? 1. Then we get x minus 3. Subtract. And we get -5 plus 3 is -2. That's my remainder, x plus 1, with a remainder of 2 over that divisor, x minus 3, and that's my answer. X plus 1 minus 2 over x minus 3, boom, done. Sampling must be random for this tip. That is, if the sample is not random, the whole thing is messed up, okay? That's the most important thing when you're sampling. So when they do this whole thing, and they're saying, hey, which of the following statements must be true? You know, what's a problem here? Well, she didn't take a random sample. It doesn't say random. She sampled people about families at a playground to figure out how many kids people have. Well, obviously, you know that's not a random sample. That's biased because only people, right, with kids are going to show up at a playground. So that's not right. And there you go. It doesn't give you an unbiased estimate, as I mentioned. Boom, done. Know where to find the formulas. Reference sheet, okay, at the beginning of the sections, both sections, domestic version, calculator, no calculator. You got to know where to find these because you get a question like this. We're talking about volume of a cylinder. It's right there, right? Pi r squared times h. And they said if the volume is 72 pi, look, I'm just plugging in. What is the diameter? and I know I got a height of 8. So I divide by pi and divide by 8, and I get 9 equals r squared. R equals the square root of 9, which is 3. Diameter is double the radius, 6. Boom, done. That's how we do it. All right, this one. In a right triangle, one angle measures x. Sine of x is 4/5. What is cosine of 90 minus x? Remember this rule. We talked about this earlier today. Sine of an angle is equal to cosine of the complement, which means if this is sine of the angle is 4/5, the complement of x is 90 minus x. This is also 4/5. Now, I did draw out a triangle because that's like what I'm programmed to do, right? You can do it this way as well. Sine of x is 4/5, opposite over hypotenuse. What is cosine of 90 minus x? Here is 90 minus x. Cosine is adjacent over hypotenuse, also 4/5. Boom, done. Okay, in the xy plane, the circle has center h. Oh, yeah, draw triangles. A lot of these circle problems are triangle hybrid problems. So it says, what is the value of k? So just think like, I'm not totally sure what to do, but I should probably draw in a triangle. Well, look at this. Look at what we have here when we put this in. Okay? We get this nice right triangle. And you might be like, well, I don't know what to do with that. Well, wait a minute. H, by the way, is occurring in between 4 and 20, exactly in between, right? Isosceles triangle, because those are both radii. So what's in between 4 and 20? It's 12. So at least now I know that my h value is 12. Now I need to find k. Okay. Well, how do we do that? Well, look at this little right triangle, 4 to 12. That's a distance of 8. And we also know that the radius is 10. All I have to know is how much did I go up this value, right? Radius is 10. How much did this value go up? Well, I got a right triangle, Pythagorean's theorem, or Pythagorean triples. 8, 10, that sounds like a 6, 8, 10, or a 3, 4, 5, right? Which means this value is 6. That means k is 6 up from the x-axis, which means k is 6. Boom, done. 34. K, so, that's yes, special request is a good idea. Let me know if you have a particular question. I'm going to try and answer it. I got to try and wrap this up, though, because I'm getting close to being out of time where I have to jump off. So let me just run through this, but throw in a question. I'm going to do my best to answer it. Okay? All right. Know your conjugates. When they say this, what is, they said it rewritten like this. How do I get it in this form when I have this weird denominator? Multiply by the conjugate. What is the conjugate? It's the same thing, and that's just for the denominator. It's the same thing as the denominator, but you flip the sign from minus to plus or plus to minus, whichever way. That's what they're doing here. So if you know this, you might be like, what the heck are they talking about? To get it to a plus bi. Well, you do this, it works out perfectly. Multiply 9, 6i, negative 6i. They cancel out. And then negative 2i times 2i is negative 4i squared, which is positive 4. And just like that, the denominator is no longer imaginary. And then on the top, so that's 13. And then on the top, we get 24. 16i, negative 3i is 13i. And then negative I times 2i is negative 2i squared, which is positive 2. I squared is negative 1, that's why. So then we get 26 over 13 plus 13i over 13. That is my a plus bi. Real number, imaginary part. So and then they want the a value, which is 26 over 13, which is 2. Boom, done. For these types of rational exponents, the numerator is the power. The denominator is the root. So we can quickly rewrite this as 9 to the third power to the fourth root. But I like to do the radical first, usually, but we're going to get there. And we're saying this is equivalent to which of the following? This is a hard question. So I'm seeing the 9s, and I immediately know it's obviously not the fourth root of 9 because this is the fourth root of 9 cubed. Could be the cubic root of 9. I don't know. But I also see these values with 3. Okay, that's a tip. That's a sign. Because I can write 9 as a power of 3. Because 9 is really 3 squared, right? And 3 squared to the third power, now I can use my exponent rules. 4th root of 3 to the 2 times 3, which is 6. And now I can actually rewrite this again as a rational exponent, as 6 over 4. So now look at this. I got this nicely simplified. And then I can simplify the fraction, 3 to the 3 over 2. And check this out. Now I can take it back to the radical format. This is 3 to the third power and the square root of that. Well, I can simplify that further because 3 to the third is 3 squared times 3. Square root of that is 3, and it looks like D was my answer. Okay? Okay. You said there is a histogram question. Now, I've done the digital test on my YouTube channel. So you can probably, if you look at my digital SAT test, you can see where I do that histogram problem. So I would definitely look at that if you guys are looking for digital SAT in particular, like where I'm doing the walkthroughs. All right, next one. Know how to identify roots. Roots are the x-intercepts. There's a root at -3, a double root at 0 because it bounces, and then a root at 2, which means I should see in the factored form x plus 3. I should see in the factored form x minus 2. Whatever the roots are, it's x minus that. And then since it's x minus 0, which is just x. But since it's a bounce, that x should be to the second power. Okay? Or to the fourth or to the sixth, but it's probably going to be squared. And that gives us b. That's it. Know the constants of quadratics. Okay, we have vertex form, and in this case, we see there's my vertex, and it's my, well, actually, it's in vertex form, meaning the vertex of the original is 0, comma c. C is obviously some positive value. I don't know what it is. A is also positive because the function is going up. Okay, great. And it tells us the vertex is at 0c. Which of the following is true about the parabola with the equation of this? Okay. Well, since a is positive here, making it -a means it's going down. We already know that c is positive. C is still the y value of the vertex, which means the vertex is still at c, but it's also at b. Because if you remember from vertex form, it's the opposite of whatever's in here is the x value of the vertex. So I got a vertex at BC, and I'm going down. Almost, but it's not opening up. Yep. Nope, nope. It's not -b as I mentioned. It's positive b because it's the opposite. All right, next. Know the formulas for arc length and sector area, which we talked about earlier in the video. So we got a circle with center O, and we've got a central angle in radians, 5 pi over 4. The area of the sector is what fraction of the area of the circle? Well, as I mentioned, if you think about the area of a sector, all you're doing is central angle divided by 360, or in this case, radians, 2 pi, times, and it's that fraction times the area. So really, what they're asking is, just give me this fraction. I don't even have to calculate the area of a sector and divide it by the whole thing. This is good. And then we simplify this, so it becomes keep the top, change the division to multiplication, and then flip, multiply by the reciprocal of this, cancel. We get 5 over 4 times 2, which is 8, 5/8, boom, done. Oh, 21? Yes, Aylin. Okay, so you're saying 21 on... Oh, yeah. I can do that. Okay, so solve 21st question from test 4, module 2. Okay, give me 1 second. I'm going to get to it. Let me just get through this. Okay, next, know the formula for a circle on the coordinate plane. Again, the formula gives us the fact that we got a center at -3, 1, and a radius of the square root of that, which is 5. So this is really important because we can kind of get a rough graph and figure this question out. -3, 1 is my center, and then the radius is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we kind of have a rough idea, okay? This is not the best circle. But that's -3, that's 1, that's 2, okay? And, oh, look at this. This is 2, 1. Look at this point, 3, 2. It's so obviously out of the bounds, right? 0, 0's in there easily. -3, 1 is obviously in there because that's the center. And then -7, 3. We're at -3. I mean, that one's close, right? Here's -4, -5, -6, -7, something like that. And then up 3. Ooh, I mean, it's close, but it still looks like it could be in the circle. It's probably right on the circle, or like maybe it's still right in there. I don't know. My drawing's not the best. 2, 3. I mean, yeah, it's probably inside. I just approximately, but 3, 2 is clearly outside. Okay. All right. This tip, pay attention to the sample. Okay. Which of the following conclusions is best supported? And remember, a random sample were caught, and the sample contained 150 largemouth bass, of which 30% weighed more than 2 pounds. Okay. So majority of, oh wait, sorry, one sec. Random sample of fish. The sample contained 150, and it says 30% of the 150, right, weighed less than 2 pounds. So the majority of all fish, I mean, I don't think we can say that because they're only talking about the largemouth bass. The average weight of no way, right, is approximately 2 pounds. It said 30% weigh more than, I mean, this thing is crazy. Approximately 30% of all fish. Nope, because that's not what they were talking about. Approximately 30% of all largemouth bass in the pond weigh more. That makes sense because that lines up with our sample, and then the subsample, you could say, of the largemouth bass. And 41, SOHCAHTOA. As I told you guys, got to memorize it. Now, these are similar triangles. What's also interesting, if they're similar, is I don't even need to really look at this value. I just say, hey, what's cosine of E? Well, E and B are the corresponding angles. What's cosine of B? And what is SOHCAHTOA? For cosine, it's adjacent over hypotenuse. Adjacent over hypotenuse. 12 over 13, which is B. Boom. That's it. Okay, that's it. Now we're going to go to the Q&A. Oops. We're going to go to the Q&A, and we already have our question. Can you please go through that question again and solve it? Yes. All right, so let me see how I can pull it up here. I've got the digital test. One second. Let me see if I can find it over here. Whoops. Okay. Let's look real quick. I'm going to get the PDF version. Digital, where is it? There it is. Okay, so test 4, module 2. Okay. Let's see here. All right. Well, this is the PDF version. Let me see. The questions may not line up with the digital. So you said a histogram. Here's module 2. Oh, here we go. All right, let's see. You're not talking about that one, right? That is the Wait. Aylin, which one are you, did you see it? Are you talking about this problem here? 24? Oh, hey, what's up, Sanvi? Well, you're seeing me live, so welcome. All right, Aylin, are you still here? That's 21. Yeah, but Aylin, it might be different numbers because I have the PDF version here. So look and see if you, because look, 21 is this. Is this the one you want? All right, so Aylin, are you seeing this or no? Nope, that's not it. Okay, shoot. I don't know. This is, wait. Yeah, I don't know. It's not showing up on this one, I guess. It's so weird. Because this is supposed to line up with the blue book. I just can't, I won't be able to, I just won't have time to like open the app and like get, all right, so how about this? I'll do one. Hey, Robert, you're welcome. Thank you for joining. Good to see you. So Zane, you want test 4 module 2 question 26. So I assume this one. So let's see here. Let's pop it on a whiteboard. All right. Guys, I think I'm going to do one last question because my voice is getting really tired. Okay. Okay. All right, 2 identical rectangular prisms, each have a height of, here, let's do this real quick. Have a height of 90. Okay. The base of each prism is a square, and the surface area of each prism is K, okay? If the prisms are glued together, so wait, are they, oh, they're identical. Okay, they are identical, got it. So we have a height of 90, and their bases are squares, okay? The base of each prism is a square, and the surface area of each prism, the square are glued together along the square base, so along the bottom, or I'll highlight the top, how about, since we can see it. So they're gonna be glued together right there and right there. The rectangular prism has a surface area of that. Okay. What is the side length? All right. So let's see if we can figure this out here. So we get a height of 90. So we can say that, let's see here, perimeter. All right, so so it's a rectangular prism, so it's like, I'm trying to think what makes the most sense here to approach this, because we have 4 sides on each. So we could say 4 of the big sides plus 2 of the bases is equal to K. And then that height of 90, how can we bring that in the mix? Because let's see. I mean, I know we can do the formula. Surface area is 90 times the perimeter, which is, we did 90 times the perimeter plus, So that's k, and then we glue them together, which would be, so 4x plus 2y equals k. Oh, wait, maybe we can do like a system here. Yeah, I guess we can do a system. All right, so this is what's coming to me sort of in the moment. I don't remember how I solved it when I did it live, but this is sort of my representation. This is the faces, like the lateral faces, and then y is the bases. And then now when we glue them together, we'll have 4, 8. We'll have 8 faces, and then we only are going to have 2 bases again because we're kind of like removing these. We're almost like subtracting these. So then it's plus 2y equals 92 over 47k. And then it says, what is the side length of each square base? So we need this. Okay, so I think what we can do here is if we combine these, let's see. If we combine these, we get the areas of the face. Oh, let's just try this. Okay, so I'm going to use elimination. I'm going to multiply the top by -1. So I'll go negative, negative, negative. I get negative 4x plus 8x is 4x equals, and that's 1k. So we can say like 47 over 47. 92 minus 47 is, what is that, 45, right? 45. Oops, 45 out of 47k. And then each face, if we divide by 4, let's see, does this help here? 4x. So then, oh, wait. Then the bases, wait, so if this is 45 over 47k, oh, then I know that the bases is, because this is supposed to add up to k, the base is 1 over 47k. You see? 1 over 47k, because 2 times I would be 2 over 47k, add to that would be k. Okay? And then also here, that's 45, so that's double. That's 90 over 47 plus 2. Yeah, it works. Okay. So what did I say? 1 over 47 was y, right? Okay. And y is the base. So this is the area. It's 1 over 47k. I think I'm trying to see if I'm doing this right way. So then the side length of each square base is the square root of that. So it's, but this is so weird because I still don't know what k is. I wonder if I can solve for k here. Let me think. The base of each prism is square, surface area of each prism is k. 90. Wait, 2 identical prisms each have a height of 90. The base of each prism is a square. Surface area of each prism is that. But they actually get a value. Let me, oh, wait, I can't remember how I did this. Yes, and Twicey, I am uploading this, so this will be, but it says along the square base, when the length become 2x, somebody said, wait, and the surface, the prisms are glued together along a square base. I think what they mean along a square base is they're gluing the 2 bases together. That's what I think. The prisms are glued together along a square base, right? The 2 bases are glued together. I think that makes sense, right? So it's like you're almost doubling it, but just a little less. So the bases, okay. And then, so what else? How else can we, I feel like I'm not really, so I haven't used that 90. That's the thing. And I need to use the 90. So let me just think about this a little bit more carefully. If we have they both have a height, so then surface area is, here, let's see if I can come up with another way to think about this. It's a pretty tough question. I don't even remember. Maybe I didn't get this right because or in the time portion. So surface area equals, well, that's kind of what I have here. 2 times the base, area of the base, plus perimeter times height, which doesn't really help, right? Oh, no, because perimeter is 4 times the side length. Maybe that helps. 4 times the side length, which I'll call S, times 90. And then now I know that the surface area, oh wait, maybe I can solve it this way. Surface area of the whole thing is K equals 2 times the base, which is, we already got the area of the base, which is 2 over 47K plus 360 side length. But this still doesn't really, this would be me then 45 over 47K equals 360 times side length. And then it says, see, but this still gives it to me in terms of K. That doesn't let me solve for K yet. You took a system of equations, somebody said, and they did, oh, they made it, they did 2s squared plus 4 times 90s, kind of like what I did, equals K. And then, oh, for the second one, oh, that's smart. That's smart. That is, wow, this is a really tough question. Okay, so we've got this equation. And then I think they said they did the second equation, which was 2 times, shoot, I don't even know if I'm going to have time to finish this because I'm going to have to go soon. If we have, God, wow, that is a lot of work. Okay, so then they did 2s squared plus 4 times 90, right? Oh, got it. So, okay, this is the system that they've proposed. Let me see if I can get it real quick. So they said 2 times the side length squared plus 4 times 90 side length. Right? That's 2 of the bases plus the lateral sides equals K. This makes more sense, actually, because now we get a system that, yeah, this is so much better. Okay, and then they do the other one, which I laid out here, 2 times the base, but they just did everything in terms of side length. That's bad. That's what I should have done. And then plus, and then we have, instead of 4 times 90s, wait, they have 180s. Now, does 180s make sense for the combined? Because it's 4 times 90s. 4 times... Shouldn't that be 4 times 180s? I think you missed a 4 on the thing. But anyways, because now it's double that. It's now not a height of 90. It's a height of 180. But we still need 4 times that. And then now this equals 92 over 47K. Man, this is tough. So, and then using this system, right, you can basically multiply this by negative 92 over 47. This is going to be a lot of work, so I don't think I'm going to be able to finish it. But you multiply the top by negative 92 over 47, distribute everything, and then you can eliminate the K and then solve from there, adding these together. Boy, oh boy, that's going to create a quadratic. I don't know. It's a lot of work. You could do it in Desmos too, because once you get this equation, you plug it in Desmos, and you can solve it that way. Yeah, so Twicey, it's basically taking this through and then solving it as a quadratic once you combine this system. But it's just like a crazy amount of work. It's a really difficult problem. So anyways, guys, my voice is dying and I got to jump off because I have some other work I got to do this morning. I want to tell you guys all something. I want to tell you, first of all, thank you so much for joining. Thank you for all the likes and the support over the years. I really appreciate it. And I really hope this stuff has been helpful for you guys. I wish you all the best of luck tomorrow, whether you're taking the digital, whether you're taking the domestic. I wish you all the best of luck. Make sure to get good rest and eat healthy. Don't eat too much sugar. That will help to keep your energy levels high, your brain sharp. And that's it. Thank you guys so much for joining, and I will see you in the next video. Take it easy.